My name is Nimesh Sakpal. I am a mechanical engineer. I have done PGDM with dual specialization, MBA in operations and IT. I have total 4 years of work experience, and for past 2 years I have been working with Kaizen Institute. Today, in this session, I am not going to talk about technology because technology is not the thing because of which Industry 4.0 will fail. It will fail due to lack of preparation. So to begin with, there are few terminologies that we should understand. First is, what is digitization? Digitization is nothing but converting analog data into digital interface. Then digitalization is employing the digital technologies to transform business operations. And then digital transformation. It is about transforming all the business activities. And then comes last, Digital KAIZEN transformation. So this digital transformation, it is not a jump, it is a journey, and most of the organization, they fail somewhere between digital transformation and digital Kaizen transformation. Most of the company, they start this Industry 4.0 implementation in silos. They start with digitizing some operations. They start with digitalization of few operations. And this transformation, it is getting from basic data to insight to culture building. So today's agenda, in today's agenda, we are going to talk introduction of Industry 4.0, then what are the future challenges, then what is our role as a OE expert, and what is the way forward. To start with introduction, industrial eras. First industrial evaluation, it happened in 1777. It was about, it wanted to solve a problem of individual craftsmanship, replacing manual work with standard work. Then came Industry 2.0. It wanted to solve a problem of speed of production. Then came automation. It wanted to solve problem of human efforts. And then digitalization, Industry 4.0. It was about use of data. So what exactly is Industry 4.0? This research started in 2006 with German government. They wanted to deploy digital technologies in factories. And research concluded in somewhere around 2013, where the first keyword they coined, which is smart factories. So when we talk about Industry 4.0, is it about 3D printing? Is it about IoT? Is it about AI? Simple answer is Industry 4.0 is not about these technologies. It is about ability to capture this data and access it anywhere and act on it immediately. Excuse me, this display is not working. This both of this. So, okay. So what do you think Industry 4.0, why it is happening? Is it because of new technologies? If you see in this slide, internet, which enable Industry 4.0, these all are the enablers. Internet, it came in 1969, ARPANET, firstly introduced by US Army. Then personal computers, they introduced by IBM in 1981. Then industrial robotics, introduced by Uni 8. First installation of this robots was in German Motors, General Motors in 1961 in Switzerland plant. Then wireless networks, 1997. Then AI, first AI logic was built in 1943 by some mathematician. Then the websites came in 1990s. And then IoT devices founded in 1988 when few college students, they used to run out of Coke bottles from nearby vending machine. So they invented this IoT device so that replenishment cycle can be easily tracked with IoT device. And 3D printing founded in 1986. So this slides, it want to tell you that it is not technology. All this technology which are going to be used in Industry 4.0, they are old. So what is the triggering point? Why we are talking about Industry 4.0 right now? So can anyone do anyone know what is Moore's law? Gordon Moore, he gave this law in 1965, around 1965. He is one of the founding member of Intel. Anyone? Okay. So the law is, in every 2 years, the density of microchip, it will increase significantly, while the cost of microchip, it will go down. And this is the triggering point for Industry 4.0. I'll give a moment to read this. Shall we move forward? Yeah. Yes, sir. Okay. So, paradigm shift. All this industry revolution, they happened to solve some kind of problem. It didn't happen on its own. And what they wanted to solve is flow and variation. Flow and variation on floor. When we talk about flow, flow is nothing but muda-free operations, which are transportation, inventory, motion, waiting, overproduction, overprocessing, defect. Then variation. All this industry revolution, they happen to manage variation. Variation in customer demand, variation in speed, variation in quality, variation in working rhythm, variation in skill of operator and workload. So the goal was always to master the flow and variation to achieve quality, delivery, cost, and flexibility. This flexibility part we'll talk in future challenges as well. And what Industry 4.0 is doing, it is looping all this data together. So what we understood history. We understood that Industry 4.0 is old technology. It is triggered because of Moore's law. And all this is happening to manage flow and variation. Then, what are the future challenges? First challenge is exponential changes. So it is not about change anymore, it is the rate of change. And if you can see this matrix, we have 4M, method, machine, material, man. And if you see the resistance level, resistance will be felt more at manpower level. Method and machine, they are near to zero level of resistance, and then some resistance at material level. Then another challenge is manufacturing companies will face is de-skilling. So with time, all the experienced people in factories, they will get retired, and all the Gen Zs and Gen Alpha, they will get into manufacturing facilities. And what we need to do is we need to program all these skills of experienced people into machine itself. And sustainability. Sustainability was till now an obligation to many companies, but with time, people will see it as a competitive advantage. And in previous slide, we talked about flexibility. Flexibility to manage low volume and high variety, high mix of product. Because now customer, they don't want similar product. They want different packaging, they want customizations, and they were willing to pay premium to achieve this. And last challenge, which is cost. Customer is demanding maximum value for what they are paying, but bottom line remains the same. So what it's creating a cost competitiveness. So till now, we understood history, introduction, we understood future challenges. Now what is the role of Kaizen experts? So I often hear that we are going for automation, we don't need Kaizen, right? So this is the biggest misconception. As you can see in this chart, volume of digital automation, as it increased, criticality of OE will increase as well. So what OE experts, what Kaizen experts, we need to see why this digitalization is required in our value streams and who all are be affected by these digitalizations. So this is where our role lies. The more we digitalize, the more OE comes into picture to structure that data, to define value streams, and to manage change. All this innovation related to digitalization, they are simply a Kaizen mindset where we keep asking same question even after improvement. What else? How much more we can improve? This is called continuous improvement. Shall we move forward? Okay. So, what is our role? To create Muda-free and standardized digital-ready value stream. This slide was explained earlier by Mr. Grover as well. We'll go through again. So our role is to assess our current maturity level. We need to see that our factory, is it still in industry 2.0, is it in 3.0? Did we started with 4.0? So what is our maturity level? And then we need to identify value streams where standard work is in place, where flow can be established, where variation and waste are understood, so that we can take decision related to, in that value stream, on that operation, we required to do Kaizen first, we required to do improvement first, or we can directly deploy this digital enabled tools. So Kaizen experts' judgment remain critical in deciding when and how to digitalize. So this is the statement: technology on bad processes is nothing but a lipstick on pig. This statement was given by MIT professor David Hardred in one of his lecture. What he wanted to tell is slapping all the IoT sensors, cobots, robots in flowless and variation high processes, it will do nothing but it will make mistake faster to track with more accuracy, right? So industry 4.0 integration, it should look like this, not like lipstick on a pig. It will make you look modern, but the problem will be remain same. So we need to see that industry 4.0, it is not just another IT project, it is collaboration between manufacturing, then OE experts, Kaizen experts, and tech experts, so that innovation can happen collaboratively, right? So integrated approach, this was explained earlier by Grover sir. Most of the company, they directly start investing in digital transformation, which has high cost, but significant results that can be achieved if Kaizen transformation is enabled by digital transformation. It will give greater results. So the core engine of 4.0, as you can see, in most of the factory floors, the data is still captured on analog method on paper, and that can be easily lost, that can be easily manipulated. So I visit client sites more often, and then I see that some breakdown information should be there in that paper, but minor breakdown, minor stoppages, they skip those minor stoppages when they are recording this information. That can be avoided with digital tools. These are few variable interface we need to think of when we are thinking of implementing Industry 4.0. So it improves accessibility and communication. For example, on floor, I'm having this wearable device, smartwatch or smart glasses, and at some place, the place is hazardous. So the safety instruction that can pop up in my smartwatch itself by GPS tracking, so that can happen. That then exact logging, so log time, location, content, machine status, that can be logged with smart devices, smart wearable devices. And also information can be sent to these devices where it reaches to right person instantly. Okay. So what are the functional pain points? These pain points was written by one of our director in 2016, 10 years back, and they are still current. So what are the functional pain points when we are thinking of digital transformation? What should be addressed in production? I'm catering enough data, but I'm not able to generate information from that. And in maintenance, can I reduce my spare part inventory by 3D printing? Safety example I've given earlier. And then on people's part, to make employees future ready, what Industry 4.0 skills, knowledge I should be teaching them. So these are functional pain points. I'll give you a moment to read out. Shall we move? So when we talk about Industry 4.0, people immediately think of softwares, ERPs, dashboards. What it creates is it creates functional silos. Most of the company, they installed ERP system, they installed HRMS system in functional silos. There's no connectivity in between them. What Kaizen tells, you first decide your value stream and then identify which digitalization tool you need to implement. For example, if you map a value stream and then decide, you will get to know that capacity planning or production planning, those applications, those software are required much instead of these other ERP softwares. What it creates, it creates garbage in, garbage out systems, which later create issues on floor. So let's understand this with one example. So this is the dashboard I have seen in many factories where they have implementation IoT devices for OE tracking. So if you can see, this is the main dashboard. The company has 50 CNC machines in one department, and all the CNC machines, they have installed IoT devices to track OE, and they will show this kind of dashboard, all the OE, all the machines together. So at first glance, you can see that there is some problem in here. There are so many red boxes, so many yellow boxes, but there's no direction on which you need to act first. You cannot understand from this. But when you do value stream execution, in that we create cell of machine. Instead of doing it for 50 machines, flow improvement, it tells that create cell of 3-4 machines for each value streams, and then you track OE. So you can see that for value stream A, we have created cell 1. For value stream B, we have created cell 2. And for value stream C, we have created cell 3. So it is there on shop floor as well. It is not like lying 50 machines, 50 CNC machines all together. It is, they are divided in cell layout, cellular layout, and then accordingly dashboard is built. So if we do this, you can see that in OE dashboard, you can see 90% availability. Due to what? Due to stop loss at machine number 2. In cell 1, machine 2. Then value stream B, cell 2. You can see that availability is less because bottleneck machine. In this, you cannot identify what is bottleneck machine. In value stream wise dashboard, you can see what is the bottleneck machine, and due to which your cell efficiency, cell OE is going down. In this, what will happen for 50 machine, one factory level OE will be there, but in value stream execution, you will get value stream wise OE, which will bring more clarity. Are you guys getting? Am I connecting? Yes? Yeah. Thank you. So, reality of this digital transformation. First thing we need to understand that Industry 4.0 is not some software-based solution you can install on your factory and then it will solve your all problems. And it can bring it can add massive values, but you need to organize it with value streams first. And it is continuous improvement journey. So till now we understood introduction, history, then what are the future challenges, what will be our role. So how actually we prepare for Industry 4.0? We'll see this digital roadmap, and after that we will see what is the Kaizen knowledge model. So in digital roadmap, as we are listening to this from morning, that it should start with people, then process, then technology. So improve your processes, then choose appropriate technology, and do change management for your people, while keeping in mind first principle of Kaizen, which are add value, eliminate waste, create a flow, involve people, go to Gemba, and visual management. So this is the digital roadmap. At level 1, we are making lean processes, and then digitization, which is nothing but converting analog information into digital information. Then real-time information passing and data availability. Then knowledge, business and intelligence, predictive analytics. Then making it interactive, connecting and interacting of cyber physical system. And then intelligence, autonomous decision making and self-learning system. So you'll see that we are going from reacting nature to predictive nature. So in the next slide, I'll show you how at level 5 factory will look like. You can see this is the raw material. This is my machine 1, which is doing operations. Then machine 2, which is doing assembly work. And then final output, machine 3. You see, when we'll input a raw material, it will process, it will give a data to machine 2. In between, it will give a real-time status of error, and likewise machine 1 will improve. Then machine 2 will pass the product to machine 3 while giving quality feedback, and then automated adjustment at machine 2 will happen so that we get right product. So in Industry 4.0, machine will exchange information autonomously with each other. With minimal human intervention. Level 5 intelligence. Okay. So till now we understood Industry 4.0, challenges, our role, how digital roadmap will look like. Now comes our knowledge model. It starts with foundation. You need to develop digital competency of your people, then develop a digital governance system, cyber security, digital ecosystem collaboration, and agile implementation, governed with Digital KAIZEN, Project KAIZEN, Strat KAIZEN. Application area will be smart development and smart operation, which is nothing but Industry 4.0. Then digital services for your offices and technology, automation, digital information flow, and advanced analytics. So we'll see this smart automation part, which is related to Industry 4.0. If I show you what are the pillar of Industry 4.0, these are all the technologies. And if I highlight all this technology in our knowledge model, so we saw smart operations in our Digital KAIZEN model. And in that smart operation, we have process automation, digital information flow, and advanced analytics. All these highlighted points are nothing but pillar of Industry 4.0. So if I ask question, how many of you know what is value stream mapping? Can I see hand raised so that I understand? Value stream mapping. Correct. Okay, great. So if you see in this model, this process automation is nothing but a material flow. So when we talk about how to implement this Industry 4.0 in your factory, you need to understand to look at it with value stream spectacles. So material flow is nothing but process automation. Information flow is digital information flow, and where decision making is required will be covered by advanced analytics. So we'll start with process automation first, which is material flow. Automation is nothing but converting manual task into automated task. How to implement it? Map material flow in your value stream, that identify what are the automation gaps, identify what are the best automation solution, we'll see that, and then evaluate ROI, and then create a roadmap. So first tool in process automation is Karakuri. Karakuri is mechanical device which will assist you without any electric, pneumatic or hydraulic power. It is used for less expensive and easier to maintain. It is easier to improve. Then another tool is industrial robots. So for now you can imagine your value stream, and then in your value stream what are the operations, and then you can start thinking of where this automation can be applied. You can make your value stream on your paper as well. Then industrial robot, they can be used in welding, car body assembly, painting, materials transformation, machining. Then comes cobot. We understood what is cobot in morning. It is nothing but it is designed to work with human employees. They can be used for pick and place, machine tending, packaging, quality inspection. Then IADs, intelligent assistant devices. There are two types, manipulator and exoskeleton. They are wearable devices. They are used to amplify human strength. Going forward, we have additive manufacturing, 3D printing, which is layer by layer material adding. They are used for visualization of tool design, then creating highly customized product. Another tool is AGVs. They are used for material movements. There are a few types, mixed fixed path system, then laser guided system, laser inertia guided systems, and then autonomous mobiles. And the last one, warehouse management. It is used for storing and retrieval of product. Now comes digital information flow. Digital information flow is management of information technology and operational technology together. How to implement? Again, imagine your value stream, understand what is your information flow, that identify digitalization gaps. Then we'll see what are the digital solutions to fill these gaps. then evaluate ROI, and then create roadmap. So digital information flow, it starts with sensors. Sensors are used for temperature, pressure, radiation measuring. Then comes EIDC, automatic identification and data collection, barcode systems, RFID systems. Then comes industrial control systems, SCADA and PCS. If I can zoom here, you can see start with corporate network, then supervision network, and then production network. Where PLCs are used, where SCADA is used, you can understand with this image. Shall we move? Then comes Internet of Things. Internet of Things is nothing but interconnected computing devices. It has edge computing and then cloud computing, and there are data gateways in between. If I enlarge this image, so at edge computing, all the sensors, actuators, controllers will be placed, and there will be a data gateways to transfer this data to cloud. So this is how it will look like. So these are some tools related to digital information flow. There are more. Manufacturing operations management. It has production operation management, then quality, QMS systems, WMS systems, all this. Then business applications, all the ERP systems, and then vertical and horizontal deployment. Once you do all this for your one value stream, this can be implemented horizontally as well. So this is very important. This pyramid is made by ISA, which is International Society of Automation. And if you can see that at level 0, machine physical equipments are there, and at level 1 and 2, all the sensors and IoT devices will be there. But most of the organization, they start with level 4. They directly implement ERP systems and all. So this is the pyramid we need to keep in mind when implementing these all tools. Then comes VR, virtual reality, used for prototyping, assembling, fault diagnosis. Last point, advanced analytics. Advanced analytics is examining all this data which we captured in our information flow and how we can generate insights. Method is same. Do value stream mapping, then map your process flow, then decide where decision making is required, identify gaps, evaluate ROI, and then roadmap. So this slide is, I've taken this slide from our global repository. It clearly tells how data is moving from past to future, what is historical data analysis and what is future data analytics. It starts with data mining, where descriptive analytics happened, and then diagnostic analytics, then monitoring with digital twin and process mining, and then predictive analytics, regression model, factor analysis, and then optimization. and AI. This AI part will be covered by my friend Dhananjay. I think, Shivraj, you should call Dhananjay. So all this historical data, it is related to traditional analytics, which is called as business intelligence. And this forecasting and all, it is advanced analytics, which is data science. Okay. So till now we understood introduction, history. Industry 4.0 is not old tech, it is triggered because of Moore's law, then flow and variation, what are the future challenges. As a Kaizen expert and OE experts, we are supposed to create MUDA free value streams, integrated approach of digital Kaizen and digital transformation. What are the functional pain points in manufacturing, quality, safety, and people, and what is the reality of Industry 4.0 implementation. We saw digital roadmap, we saw Industry 4.0 knowledge model, how with value stream mapping you can map your process automations, you can map your digital information flow, you can identify where advanced analytics can be applied. We also saw International Society of Automation, that data model, which tells at level 0, at level 1, we should start with sensors and IoT devices, and at level 5, all the softwares will come in place. So with this, if I ask question, how to implement? So first question you should have in mind is my material flowing on my floor? Then the second question, have I managed my variations? And the third question, are you truly done with smart automation? If yes, then you can start with digital information flow and then advanced analytics. So with this, I'll end my presentation with one line, that do not digitalize MUDA and MURA. Do Kaizen first and then start with digital implementation. Thank you.
Good morning, everyone. So this is the second half of the entire session that is preparing for the AI era. My name is Dhananjay Sarvekar and I'm a support consultant at Kaizen Institute. So today we'll be looking at the very important question, which is how do organizations practically prepare for all this AI transformation in a very structured way. So most of the basic foundations and the strategy part has been covered in morning sessions by both of our key note speakers and Mr. Grover sir. But we'll try to focus on the important parts that are not being covered, and we'll have this session going ahead. So to begin with, I would like to start with a simple thought that I believe sets the context for the entire 30 minutes, is that there's a common saying in operational excellence that if you automate MUDA, you do not create efficiency, you just simply create the digital MUDA, right? So AI is nothing different from that. So the code goes on. AI does not create operational excellence. It just amplifies the level of excellence that is already built into the system. So the agenda is very short. We'll just begin with the AI landscape, what is actually happening at the global level, followed by how operations are becoming smarter, then how successful AI transformations are being led, where the transformation have higher chances of failure, and we'll just end up with how organizations should prepare themselves for AI-ready operations. So before discussing implementation, it is very important for us to understand the broader dynamics of how at global level the implementation of AI and acceptance is happening. So this is basically a report from McKinsey which states that around 88% of organizations at global level report using AI. But when we come down, just 31% have roughly begun scaling AI into their operations. And the last one being just 5% have achieved financial gains since implementation of these initiatives. So to understand, so the overall, this is what tells us that while AI interest and momentum are going rapidly, most of the organizations are still in the journey of towards meaningful adaptation, and we cannot directly say that we have started adopting them. Like we are at the beginning of journey, and to understand this journey, where it is heading, it is equally essential for us to understand how the evolution of AI has been. So just in a summarized way, we started from basic rule-based automations. Then we have seen machine learning applications coming in. Then Gen AI models built developed for the internal applications. And now we are in the phase of we have been listening the implementation of AI agents and in our regular operations. So this is how the AI is actually evolving, and before that we have seen how industry is evolving and how it is adapting to that. So moving ahead, I'll not go into the depth of these as my colleague Nimesh San, and also in the morning Grovan sir has explained in detail about the knowledge model and how we are looking at smart operations and how AI is an important enabler for smart operations. So this is very important. So we have to understand how the paradigm shift is happening from traditional industry models to how the intelligent operations are being developed. So initially the operations were mostly reactive reactive based, periodic reporting, and mostly human-based and judgmental thing. But now it has been predictive and proactive decisions, real-time operation intelligence, and human plus AI decisions are being taken. And we are in the time of dynamic adaptive planning. So this has been the paradigm shift that is happening and we are seeing. So that's the summary. Like enterprises are evolving toward one intelligent way of operation. So as Nimesh San rightly said, that we have to see in a value stream point of view, and across value chain, if we have to see, we have applications of AI, right? Not just in planning, but in sourcing, in production, quality, as well as in delivery. So in our morning session, one of our keynote speakers, Mr. Datta, also briefly explained how the applications they have been doing, and this is the same thing here. So in the application point of view, we should also know that not all the business needs have single AI solution, right? So each and every application or each and every business need might have some different application, and we have them listed over here. If we talk about intelligent automation, we have to go forward with that need. Then we have to develop some workflows. Similarly, like machine learning models, optimization engines, computer vision we saw in the morning, natural language plus programming when it comes to multilingual data processing, then building LLMs for inner circle operations, Gen AI, and again the AI agents, right? So for every business need we have, or the industry in AI is evolving in such a way that we will have more applications moving ahead. So to connect with, Industry 4.0 basically gives us the digital infrastructure and connected systems so that the convergence with AI sets right, and we actually get the higher no, the business impact right and in right direction. So it is very essential for organizations like us to understand how or at what maturity level we have implemented Industry 4.0, and so that we start preparing for the AI era. So to understand successful AI transformation, we need to understand what are the common reasons of failure that we have been seeing in the industry when it comes to AI transformation. The first one being it's often pursued as a technology initiative, so we need to think upon that. Then we mostly the common reason is process maturity is not being developed internally, and that is one of the reasons why we basically digitalize Muda, as I mentioned earlier. Then the data source is fragmented, weak digital infrastructure within the premises. One of the other reasons is lack of workforce readiness, which also one of our keynote speakers mentioned how we have to build the competency within our organization in order to understand and go ahead with the implementation. So these are some of the reasons why transformations fail. So AI success requires transforming people, process, and operating models, not just technology. So this is an interesting slide, basically, a research by McKinsey Quarterly, which tells about 12 themes. It was recently published, and it is very important for us to understand them. So these are basically in very detailed form, but I have just listed the titles of them so that in shorter time we can just run through. The first one being technology alone doesn't create advantage, enduring capabilities do. Then the second one is economic leverage points are our best focal points. We have to see from that angle first. Third one is if the value you are creating doesn't move business, then maybe you are getting it wrong. Fourth one being building the technology and AI muscle for your business leaders should be a top priority. We'll be speaking upon this in a later part of this existing current session. We have a separate slide for leadership Kaizen, which explains how leaders and OE experts must think in that direction when it comes to implementation. Fifth one is every tech and AI transformation is a people transformation. So this was also mentioned by Mr. Grover in the morning. Like we have to think in that way, people, process, and technology, which we call as PPT. Sixth one is speed is defining organizational advantage. We have seen organizations go from Gen AI to LLMs, and now just building the AI agents. So yes, to have a competitive advantage, we have to go through the run and actually look for the advantage gaining way. Seventh one is technology platforms are strategic assets. Invest in that way. Eighth one being make data easy to consume and enrich it for advantage. So we'll be speaking more upon this in further slides. Ninth theme is design for adoption and build for scale. The 10th one that was mentioned was no trust, no right to deploy AI. And this is very important because in current situation, we just wonder upon what kind of applications we might be using, or in what direction we have to go ahead. As Nimesh rightly mentioned, it was basically regarding the industry, like it is Industry 4.0 maturity levels. But same applies here. We have to, that will come ahead, that we have to stabilize and then look after the digital implementation. So this theme also explains the same. 11th one is agentic engineering becomes the next capability to master. So this is the current state. And last one is very important, relearn your business. Relearn like your business depends upon it. So these are the 12 themes. I would recommend everyone to go through Google and just look upon. It is very interesting quarterly McKinsey report, which describes in detail about these 12 themes, and it is very important for the leadership team to understand in what direction we have to step forward. So we have spoken upon this numerous times since morning, that before AI we have to make it lean, remove the muda, mura, muri from the processes. So we'll just move ahead. And this was the one Grover sir spoke upon, that we have to stabilize our processes through standard work, build the basic discipline at our game bar, and look after the ownership, that if that is being not in place, then we have to do the initial Kaizen and build the workforce development. Then second one is optimize the processes that are stabilized. So look after more muda elimination, create a flow, and then look for the digitalization of those things. Maybe prepare some infrastructure for data capturing using IoT devices and so on. So the journey is delivered through transformation Kaizen programs and leadership Kaizen. So these are separate modules in a Kaizen business model, which Grover sir shared in the morning. So ensuring adoption at each stage of adoption, like at stabilization, at optimization, even at digitalization, as we have a digital Kaizen model. So this is an interesting part, we should have a framework of implementation, right? We speak about people, process transformation, but there are also another pillars, or we can say another dimensions in which we have to think when it comes to implementation of AI or looking forward for adoption. So for readiness, as actually these things have already been communicated, but let's just look at it, how data as a pillar we should look at is it should be accurate when it comes to readiness. We should have pipelines having accurate data, structured data. Second one being people. So we should have internal AI literacy being developed, competency developed, and workforce readiness before transforming or before implementing any applications. Third one being technology. So digital infrastructure is very important. And fourth one is process. So when it comes to process, we should stabilize the process, standardize them, and then look for the scaling of those. And this one being very important, governance. So as it was mentioned in one of the themes in McKinsey, which we saw, that leadership plays a very important role, a crucial role when it comes to adopting new things or going a top-down approach using or implementing AI applications. So governance is very much needed, and we have another slide, leadership Kaizen, which speaks about the same. So strong foundation unlocks AI readiness. And when we speak about all the pillars or all the dimensions in which we have to be ready before implementing or before thinking about AI as an enabler, so the same question arises, right? What will happen to the humans, or what will happen to the people when we are implementing these technologies? So it is very clear that human plus AI. So it actually AI enhances human capability, and we should think in that direction, not just in a way of what will happen to our roles that we were doing as of now. Then as Mr. Dr. Ajay Datta said, that repetitive tasks will only shift towards intelligent systems. Then human roles will evolve towards judgment, creativity, and strategic oversight, and that will be communicated from the leadership point of view as a top-down approach. And upskilling is very essential to unlock this collaboration. And yes, intelligence scales the best with humans in the loop. So again, I got reminded of a thing, we all will be knowing prompt engineering, right? When we speak about prompt engineering, RCTFO model, how one should write a prompt in order to get the accurate results or the best results. So in that, the same thing arises is keep human in the loop. Because when we depend upon AI for actually directly taking the insights from them and just sharing or forwarding ahead, it is just like garbage being transferred to the another system and not actually taking a strong decision upon that. So it is very important that we do not just process what has been taken from AI and pass forward. We should have a human in loop, and that's where the people dimension comes in. So this is what I talked about, Kaizen leadership. We have a separate pillar in our Kaizen business model, which speaks about these 4 steps, and these are very important. As a leadership team, we must first learn to change. Then, because acceptance or resistance, we know as OE experts, we have seen how resistance comes from the Gemba and how we actually react to those resistances. So we should first learn to change as leaders. Second one, we have to lead the change, whatever change it is. So if we don't know about what is being implemented or what dimensions it will scale up to, then it would be difficult for us as a leader to lead the change. So second step is leading the change. Third one is controlling the change. This also aligns with the second one. And the fourth one, and very important, is directing the change. So times come in the leadership roles, times come when the adoption that we have planned to take ahead may not go in the direction that we that as per plan or as per strategy. So that's where the experience of leadership comes in, and that's how the people parameter is again enforced. So it is very important for the leadership team to understand how the change will happen and then regulate the decisions in that direction. So here we come to the end of this session. I haven't spoke much on the slides that were being repeated. Most of the important things we have covered in our morning session. So those are basically look after the muda in existing process, remove the muda, mura and muri, make your processes lean, then look forward to industry 4.0 applications, make infrastructure for your data, make workflows for your data, and then then integrate with the intelligent layer, that is AI, right? So the final message being, first strengthen your foundation, then enable readiness. Of course, without readiness, it would be difficult for any organization. We might get stuck in between. So in terms of people, it comes to competency development. In terms of technology, it comes to infrastructure development, and of course the leadership team. The third one is very important, that is leading the transformation, and we saw that in leadership Kaizen model, and that's how we may reach to the success. So here's a short session on how we can prepare ourselves as a leadership team and how we can enable the change at the Gemba when it comes to AI transformation.
Need to understand on control the change. What does it?
Right. So as a leadership team, when we first we understand the change that will be happening, we ourselves learn as a leadership team. Then when it comes to leading, we plan those things, how it will happen or how it will unfold when it comes to reaching from the strategy or enabler point of view until the shop floor, that is Gemba. Controlling the changes, basically we have planned some activities, some short-term goals or long-term goals, and we have set some parameters like how it will, same thing, how it will unfold. So we as a leader are responsible or should have an eye on that, like if that is going in a right direction, or it is a scope creep. So that point, in that point of view, we should have an eye as a leader. So whether the change that we are planning is actually going in the same direction. Yeah. Thank you so much.